This is how to find the reduction formula for in equals the integral of sine nx dx. First, we can rewrite this equation as in equals the integral of sine n minus 1 x sine x, because these multiplied by each other will still become sine n. Next, we want to integrate this. We're going to have to do it by parts. Remember, by parts is u by the derivative of v equals uv. Take away the integral of the derivative of u multiplied by v. So, if I take u as sine to the n minus 1 x and v as cos x, where dv has been sine x and I integrated to find cos x, then I have to just differentiate this one and I'll have all of the pieces necessary to do the integral. The derivative of this is not so straightforward. It has to be done using the chain rule. So, if I set y equal to u n minus 1, where u is sine x, and du by dx becomes cos x, and dy by du becomes n minus 1 u n minus 2. I multiply these two together and substitute back in for u, where u is sine x, giving me du by dx equals n minus 1 sine n minus 2 x cos x. Now if I put them back into my integration by parts formula, I can write in equals u multiplied by v, which is, this should be sine integrates into negative cos x. So u multiplied by v becomes negative cos x sine n minus 1x. Take away the integral of the derivative of u multiplied by v, which is n minus 1 sine n minus 2 x cos x multiplied by negative cos x. So if I change this sign to a positive, then I can write this as a squared, as cos x multiplied by cos x becomes cos squared x. This is integrated with respect to x. The next step to remember is that cos squared x is equal to 1 minus sine squared x, which can be found by rearranging sine squared plus cos squared equals 1. So if I substitute 1 minus sine squared x into cos squared x, I can rewrite this equation as the following. Now, n minus 1 is going to be integrated to any kind of constant. This because it's integrated with respect to x. So I can take n minus 1 outside and it will make no difference to this integration. Then if I multiply out these brackets, 1 multiplied by sine to the n minus 2 is still sine to the n minus 2. That should be with an x. And sine squared multiplied by sine n minus 2 becomes negative sine n. So in is now negative cos x sine n minus 1 x plus n minus 1, which is being taken outside of the integral, sine n minus 2 x. Take away sine nx dx. I can split this integral into two parts, which I'm going to do now. So in now becomes negative cos x sine n minus 1x plus n minus 1, the integral of sine n minus 2x dx. Take away the integral of sine n x dx. This should also be multiplied by n minus 1. I'm going to struggle to write that in here. Okay, so if we take a look here, this is exactly the same as our original formula of in equals integral of sine n x dx. So I can rewrite this as I to the n. This now becomes in equals negative cos x sine n minus 1 x plus n minus 1 integral of sine n minus 2 x dx. Take away n minus 1. If we bring n minus 1 to the other side, then I rewrite it as in plus n minus 1 equals minus cos x sine n minus 1 x plus m minus 1 integral of sine n minus 2 x dx. This can be expanded and then rewritten, and in take away in becomes 0, so I'm left with in equals the rest. In still equals everything on this right hand side. So if I divide through by n, then I have minus 1 over n cos x sine n minus 1x plus m plus 1 n. And the final step is to recognize that the integral of sine n minus 2x is the same as this integral here, but with subscript n minus 2. So this can be rewritten as n minus 2. This is the reduction formula for sine n x.